All right, we'll start this again. All right, so what we're learning today is how to do algebra proofs. And in this chapter, those are the only kind of proofs we do is algebra ones. And then once we get in, so we skip chapter 3 after chapter 4. We don't do that. And then after chapter 2, we skip 3. And then chapter 4 has quite a few proofs in it that are geometry proofs, which are harder. But if you really pay attention, I think you'll catch on to those for sure. So what we're going to be doing today is learning some properties first that we will use in algebra proofs. And an algebra proof, just to kind of show you what it looks like, it looks like this. They give you an equation to solve. They tell you what you should get for your answer. And then what they do is step by step, they solve the equation. And on these blanks, you say what they're doing. So it's really not that bad. So first we need to learn a couple properties, okay? The first one that we're gonna learn is addition property. And you don't have to say of equality, you can just say addition property. But if you got something like this today, would you guys know that you would have to add 4 and your x would be 11? And then what your reason would be in that column with the blanks is you would write addition property. One thing you might want to do is show how I abbreviate those. So if you want to write down add prop. And then another thing, when you're doing the proofs, you don't show your work. If you absolutely have to, it's not really wrong. It's just typically you don't. So like this part right here would not be there. You would just go directly from x minus 4 equals 7 to x equals 11, okay? Then if we look at this one, hopefully what you notice here is they're gonna subtract 5. So when you do that, this 5 is gone, and 8 minus 5 is 3. And then what you would do is write subtraction property. Now, I abbreviate a lot, but you do have to be careful sometimes. One of the properties we learned today is called subtraction property, and one is called substitution property. If you use just SUB, I wouldn't know which one you were talking about, and you would get that wrong. So what I do is go SUBTR for subtraction, and then later we'll talk about the fact that I do SUBST for substitution. Okay? So you gotta be careful not to get those two mixed up. And then you would say prop. Another thing kids do is we get to the quiz that you're gonna have next week, and they forget to write the word property, and they lose a half point on every problem that has a proof. And by the way too, proofs are gonna have several steps. They could have anywhere from 2 to maybe 4 or 5 steps. Each step is gonna be 2 points. So if you had a 5-step proof, it would be a 10-point problem. But like I said, these won't be too bad for you, I promise. Now, if I look at this one, this is x divided by 5. So to get rid of that 5, would you guys know that you'd multiply by 5? And what we would get then is x equals 20, okay? Because we'd multiply by 5 on both sides. And then multiplication, I just do MULT and then prop. Alright. Then if we look at division property, for this one, what you're gonna do is divide on both sides. You're gonna divide 5 The 5 on the left is gone. 10 divided by 5 is 2. Now, when you abbreviate division property, we're going to go div and then prop, okay? There's a distributive property and a division property, so you just can't do di because then I wouldn't know. So I do div for division and dist for distributive. All right, so now let's look at these. This is something you probably haven't learned or haven't for a while anyway. We have what's called reflexive property. And in reflexive property, what we have is that something is equal to itself, okay? It can be a number. It could be like 5 equals 5. It could be like 6a equals 6a. Most of the time you'll see it with something like this. This means the measure of AB equals the measure of AB. This is the measure of angle ABC equals the measure of angle ABC. So this is just setting something equal to itself, and we call it reflexive prop. So if something is equal to itself, it's reflexive prop. Now, if we look at this one, what's going to happen in this one is you're going to be given something that is an equation with an equal sign. And what you would do is take that and you would flip the right and the left. Kind of like earlier this week, we flipped sentences right and left. That's what we do here. AB equals CD, so CD equals AB, and that's symmetric property. You have to name it symmetric property, but some people think of this as the switch around property or something like that, switcheroo, something like that. So you take it and you just switch the front and back, okay? Then if I did this one, I have these two angles measures equal, they just flipped the left and right, so that again is symmetric property. Now, one thing I was going to tell you on this too, to write off to the side, is reflexive property always has one equal sign, okay? Symmetric property has two equal signs. So if you look here, each of these examples have one equal sign. In symmetric, they have two equal signs, okay? And now we have transitive property, and this one is going to have three equal signs, okay? Now, in transitive, what has to be true is the ending of this and the beginning of that have to be the same, and we cross those out. And then we say the outside parts are equal. What does that kind of remind you of? Like, do you remember yesterday we crossed out some stuff? Do you remember what law that was? Was it detachment or syllogism? Syllogism, it was. So this is similar to that, where the ending of one, beginning of the other have to be the same, and we cross those out. Same thing if you have angle measures. Notice we have three equal signs, and the ending of this and the beginning of that are the same, so we cross those out, and the outside two are equal. Brooke, can you shut your computer, please? All right, now, the one that I think is most confusing is substitution property. This one also has three equal signs. So just like transitive, this has three equal signs, okay? Then, notice we have our three equal signs. how transitive is different than substitution. In transitive, this and this have to be the same, and you cross those out, and the outside two are equal. If you have three equal signs and the ending of the first and beginning of the second are not the same, it's not going to be transitive. So then what you have to look at is, how could this be substitution? And if you look, they're saying x plus y is 10 and x equals 5. So I'm going to take this 5 and put it in for x, and I just pick that x out. So I substitute it in there, and I get 5 plus y equals 10. So I took x out, put 5 in there. Now, when I abbreviate substitution, I do S-U-B-S-T, prop. Okay? Remember, subtraction was S-U-B-T-R. Substitution is S-U-B-S-T. Okay? Now this last one, most kids do just fine with this one because you're familiar with this from algebra. So with this one, do you guys remember if you have a number outside of parentheses, you distribute that? That's all they did here. They went 3 times x is 3x, 3 times y is 3y, equals 10. So this is going to be distributive prop. So I do D-I-S-T prop. Okay? Now let's go here. And we are going to look at each of these and try to determine which property it is. Okay? So if you look at A, what do you see there as far as, like, what one of the properties that I did does that look like? First thing I want you to notice, it has 3 equal signs. Is this transitive? With, first of all, you guys, when it has 3 equal signs, it's transitive or substitution. For transitive, these two have to be equal, and we cross those out, and the outside two are equal. Okay? Is that what this one is? Yeah. So I'd go trans prop. That's how I abbreviate it. If you don't want to abbreviate, you certainly don't have to. Okay? Now if I go to B, let's look at that one. You start with the beginning and you look at, what did they do to this to get this? They divided, right? Didn't they divide by 7 on both sides? So here I'd go div prop. You always start with the beginning one. Now if I look at this one, what did they do from here to here? Subtracted 5. So that is S-U-B-T-R prop. Okay. Now here what they did is they took these and they flipped the sides. Do you remember what that's called? Symmetric. Yeah, 2 equal signs. You want to think of symmetric. And that one we go S-Y-M-M prop. Okay. Now if I look at E, it says x divided by 3 equals 8. What would we do to both sides of this? You would multiply by 3. And if you multiply by 3 on the left, they cancel. 8 by 3 is 24. So that's multiplication prop. Okay. Now let's look at F. What did they do? Added. They added 7 to both sides, and that would be addition prop. Okay. Then EF equals EF. Reflexive. Yes. So when something equals itself and there's only one equal sign, that's reflexive. What do you guys think for the next one? Yep, they just distributed the 4. So this is DIST prop. And then if I look at I, okay, here's the deal. The hardest ones that you're gonna have is when you have 3 equal signs and you have to determine, is it transitive or what could the other one be? Substitution, okay? So, how I know if this is transitive is the ending of that and the beginning of that have to be the same. And they're not, right? So then you look at, could they have just substituted? And what they did here is they picked this CD out and they put AB in there. And that's how they got the AB equals 5. And when you do substitution, you're gonna go SUBST prop. Okay? Everybody okay with that guy? All right, so now we're gonna get to a couple proofs. So I have to explain a 2-column proof. So if you ever do a proof in our textbook, it'll ask you sometimes to do a 2-column proof, sometimes to do a flow proof, which looks like, you guys know, like concept maps, or I'm trying to think of another name of it, but where you have like a bubble and then it goes to another bubble and then another bubble and so on. That's a flow proof. And then the last kind of proof we do is a paragraph proof in our book. I would rather you guys master one type of proof, because proofs are hard enough, than do 3 types, okay? So whenever you're asked to do a proof, you're always gonna do what's called a 2-column proof like these. If it says flow proof, ignore it. If it says paragraph proof, ignore it. Then, in a proof, you're going to be given something and you're gonna be asked to prove something, okay? One easy 3-point step in a proof is whatever you're given goes in the first statement, and on this blank we write given, okay? Whatever we're given goes here and we write given. Alright? Then, from here to here, what do we do? If you're solving, what did they do? They added 18. Do you get that? They added, right? Do you guys get that? So if they added, it's addition property. So you got to think about it. If you were solving this in algebra, what would you do to this in the first step to solve it? You'd add 18, and then you'd get 5x equals 30, so that's addition property, okay? Then you look from here to here and you ask yourself, what if they divided by 5? So that's a div prop. Don't forget the props here. And then one other thing, you guys, you can kind of check your work on these if they give you the proof, because this always is going to be this. So if you don't get x equals 6, that tells you that you've done something wrong. Okay? Now let's look at this one. Now here's another thing that can happen, is they could give you an if-then statement and ask you to prove it. The if part of your statement is always what you're given. The then part of your statement is always what you want to prove. So if they just give you the if-then statement, you'd write the if part here, the then part here. Okay? Now, when you go to start a proof, what you do is just bring this to the first step. Okay? You can't draw arrows, you have to actually write it out. But do you guys remember what we would write here? Given, free points. Okay? given. No one should get that wrong ever. Then, what you do is you try to take from step 1 to step 2, what did they do? They distributed that 2. So on this blank, you're going to write DIST prop. And if you guys don't see something, please let me know. Do you all see that they distributed? Is that easy? Okay. Now this is a step we haven't talked about. There are going to be times where they simplify an equation by combining like terms. Okay? So if you look here, they took 6x plus 2x and they just combined those like terms. And that reason I have written down here, and if you have a cheat sheet you want to add that to, you can. But whenever you simplify like terms, or I'm sorry, whenever you combine like terms, what you write on the blank is simplify. Okay? Combining like terms, you simplify. Now what we're gonna do is look from 3 to 4. What does it look like they did? They added, right? So we're gonna say add prop. Okay? Then they divided. Very good. From 4 to 5, we divided. So DIV. DIV prop. Everybody good? Yep. Can you wait till we're done? There's 3 more problems. So, if we look here, if you can't, you can go, but I'd like you to try to stay if you can. All right, so if I look here, this is what I'm given, so that they put here, and that is my first step. So this problem, we are doing this by ourselves. Okay, so they give you that's step 1. So this one is not going to have the steps going down this side. Now, when I do this, do you guys see what we should do first? Distribute. So what I'm going to get is 3x minus 6. So I distributed the 3, distributed the 3. Okay? You don't have to draw those arrows. Equals 42. All right? And you would get DIST prop. All right? Now, we want to take it one step further, so what would I do here? What's the next step? I would add 6, so I'd get 3x equals 48, and that's addition prop. Okay? Then, our last step, what would I do? Divide by 3, and I would get x equals 48 divided by 3 is 16, and that is division prop. Everybody okay with that?
Yep.
All right. Now let's go to this one, and this one has the left side done for us. So they have the given down first. Please, no one get the given wrong. If you get the given wrong, that really upsets me because that means you haven't listened at all. So here we wrote that down, and then we have to look from step 1 to step 2. What does it look like they did? Distributed that negative 3. And you'd get 55z. Negative 3 times 9z is negative 27z. Negative 3 times 12 is negative 36. And this would be DIST prop. Okay. Now if we look at this next one, can you tell what they did from here to here? Simplify. They combined like terms. Okay? When you combine like terms, that is simplify. Okay? Then, from here to here, what did they do? Add. They added 36. So my reason here would be addition, prop. And then my last thing, what did they do? Divide. They divided by 28, so that's division, prop. Okay? Now we have one more, and then we'll be done. So in this one, we're going to write down our given. 5x minus 5 equals 3x plus 7, and that is given. Now, you guys have done many questions like this in algebra, and Mr. Check probably told you guys that it doesn't matter which side you bring the x to, right? You usually bring it to the side that's going to make it positive, but it doesn't really matter. In a proof, you always have to end up getting your x on the left. So regardless what happens, I always bring my variables to the left. Okay? So do you guys, we would have in this one anyway, but do you guys realize we'd subtract 3x from both sides? And when I subtract 3x, what would I get here? 5x minus 3x is 2x minus 5 equals 7. Okay? And I subtracted that 3x, so it's SUBTR, prop. Don't forget the TR or the prop. Now, what would I do here? Add 5, and I'd get 2x equals 12, and that is addition, prop. And then my last thing, what would I do? Divide, and I'd get x equals 6, and that's division, prop. Everybody okay with that?
Yep.
Can you kind of cheat and check your work on this one?
Yep.
You can, right? All right, so you're gonna have worksheets, and again, I have to post them super quick, so give me a second to do that, and I'll put it into Schoology for you.